Hey guys, so I got a video here about one of these bigger coils that I made. I made two of them. This is the smaller one of the two. I'm just doing the testing with this one first. It looks really good so far. I'll just give you a quick sneak peek, and then this video is going to be about how it fills up with capacitance. As it draws a lot of current when it's filling the coil up because there's so much copper. There's about 5 pounds of copper on this coil. So if you're going to build this circuit, just know that it's going to take a lot of current right off the bat. So if you're using the same transistor I'm using, which I recommend if you want the same effects that I get, NT56, then just kind of top it unless you have a really big heat sink. You don't want to put too much current through it. So until it hits, like, the battery voltage usually is around where it's going to equal out. With this one anyway, somewhere around 25 volts, 22 to 25 volts, you should be safe to connect it directly to the battery if you're putting, like, I am 26 volts into it. Well, here's a schematic, and then I'm going to give you a really quick demo here, and then I'm going to attach two videos. The first time I powered it up, and then there's another one with a little bit of a different demo. So hope you guys watch them and check it out. Okay, here's the schematic first. It's exactly what it is. Here's the circuit. I'm just gonna give you a quick demo here of what I got going on. So you see I'm not gonna get out the meter or anything, but there's this meter here and it's 0. It's hard to tell. Right, so but you can see right here. What I'm showing is just really small amounts of power though. This is just like what's happening here is the battery voltage is rising. And I'll show you that too while it's still charging this big cap bank up. And you can see here's the power going into the cap bank. You can tell, right? That's not much, but it's a constant charge that's going into that cap bank. So now it's like this adds resistance, so I always put my lines direct. And here you can see the blue one, it shows the power going in. The blue one's facing this way, and the yellow one has the power showing when it lights up, the power is coming out. So what you can see here, and I have to put my finger on the battery to get it to go when I turn it on. There you go. There's the power going back into the battery, and the yellow one is barely lit, and that's the power coming out right here. And the battery voltage has been steadily rising. And I might post a video series. I've been documenting it. It's been running for a few days now, so constantly, just like this. But I want to show you something. You can see there's nothing moving there. I'm trying to do this as quick as possible. But watch. I can get it to go. Usually if I tap it, there'll be a spot where all of a sudden the circuit will start to take power. It's hard to get it though. There we go. I just had it. There, you see it? And now it's charging harder too. But it's also using electricity. You can tell right here too. You can just see with the diode. It's not much brighter even. Or wait, I lost it there. See if I can get it back to where it was before. It's touch. There you go. There, and you can see the diode's a lot brighter. It's really bright actually. I don't know if I can get it in this mode, like when I hook it up to the LEDs or not. No, not yet. Just trying to get it to where it's using, where I can see it turn on. That's hard when you have resistance in the line. It's not like it is without the LEDs there anyway, but you get the point. See, it's using energy. It charges harder though, but when I get it to where it doesn't use it, just like that, right there, is nothing. And I can verify that with the current clamp. The power that's going in is less than the power that's going back into the battery. And the voltage has been rising steadily for 3 days on that one cell right here. Just measuring this one cell. You can see there's a constant, the cap bank voltage has been rising too, so you can see that's the power going into the cap bank. It's not much, but it's still something. So I'll just bypass that. That's that, but sorry about the long intro. The videos, I'll attach them here and hope you guys watch them. Hey guys, so I've got this coil here all built. I've got another video of this same type of thing, but I was just thinking maybe I'll do this one here to show a little more clearly, because I showed a video, same thing, right after I built it. So that I'm reading that voltage off of this cell. It's recovering a little bit because I've just turned the circuit on to make sure I had it connected properly, and it's pretty hot right now. It's cooling off though. Pulls a lot of current, and you'll see what happens. So the green meter is connected to the capacitor there. It's a 10,000 UF 63 volt. That meter is connected to this cell right here. This one's on, it's fully charged, pretty much 26 volts, 26.6. Capacitor's going up just because that's what they do. I just discharged it with the microwave oven bulb, wherever I put it. It's around here somewhere. But whatever, I'm just gonna have the negative right here. This meter's bypassed right now because it just pulls too much current. But I have my clamp meter is right there. And the positive's already hooked up right there, and here's the meter here. But it's gonna pull a lot of current. And the last time I did this, it settled off at around, the capacitance in the coil is the reason why it's building up so much current. Because you have to fill this coil up. Once it's full, then it starts to do its resonance, hits its frequency, and the last time I did it, the current went to pretty much zero. Very, very small amount of energy to make this coil work. Oh, here we go. I'm just going to tap it because I don't want to kill that transistor with just it being on until I get to about 500 milliamps or so. And then maybe I'll, once I get to that reading on this gauge, I'll change this lead over to over here, and we'll be able to watch it go to zero. The way it is right now, it's at zero. So I'm just going to keep tapping it here. You can see those are huge inputs of current. See the bottom down there? Actually, I have this on there backwards. I like reading it the other direction. It's easier to see on the scope. Put it like that. I'll be able to see it on the scope better. Sorry about that, guys. I never tested it. Just a raw video. There, now you can see. So it's somewhere up here. That's like 3 amps or so. Just under, it's just under here. And it'll keep going down. It's a DC current, what I'm reading, so that's why it's just staying steady. It's going to stay DC until the capacitance in that coil is to where it'll start to resonate with the transistor. And you can see, I'm sorry, I should be showing the capacitor voltage increasing as I'm doing this. It's because it's pretty much just taking that raw DC out of the battery to fill that coil up before the coil starts to actually get into resonant mode. Still pulling quite a bit. See what that is. Once I get to about 500 milliamps, I'll be able to hook up this other meter. And you'll be able to hear the coil start to come to life. I just don't want to overheat that small little transistor. Once it's running and resonating, it doesn't create any heat at all. That's probably pretty hot now. Yeah. Very hot. It'll be alright though. You can hear the coil starting to come to life. You can see it in the scope too. You can actually hear it. Now you can start to see the ripples in the scope. So now I'm just going to turn this meter on. We're high enough on the cap value. Now you should see this one come to life. There you go, 500 milliamps. So now I'm just going to leave it hooked up. Turn the sensitivity down on this one. Oops. Sorry guys, I'm trying to do everything here at once. Somewhere around 44 volts last time. The ringing stops. The current goes to 0. And the charging picks up pace a bit. You can hear it going through the tones. The current's coming down. Transistor's probably still pretty warm though. Yeah, really warm. Hope you can hear that. Kind of hear going through some frequency changes. See the scope is I've changed the sensitivity down. I'd have to zero it out again to get it to be center line, but you can still do the readings like that. Watch as this coil fills with capacitance. All of a sudden it just goes to zero. On this gauge it's still reading. Pulls current still low, but it's a few milliamps. Might be a bit different too because the transistor is pretty hot. It varies to where the coil will fill up. There you go. I missed it actually. And the higher it goes, the lower that'll get. See, the scope has changed. I'll turn this off again and I'll bring that cap down just to here because I want to see where it did it. This time I missed it. Try to do it without shorting it. $33 volts should be enough. Turn it back on. And the transistor is really hot right now. Last time I did it, I didn't have it that hot. See, it's slow too when it's filling the cap up. Not the cap, the coil up with energy. It's slow to charge. And it's just like you hit a switch, all of a sudden it just goes to zero almost. There you go. Way less this time. 43 volts. It all depends on the heat and stuff in the cap and the transistor. And it charges faster. The higher the voltage gets, the current will go to where the needle doesn't even move anymore. Especially when the transistor is cold. Right now it's scorching hot. So it's not very efficient. You see the scopes coming to life with the frequency. I've had it steadily charging this big cap with the gauge 0 and the scope reading milliamps 3 to 20, like up and down type of thing. I'm going to stop it at 60 volts because it's only a 63 volt cap. still pretty hot. Yeah, it's cooled down a lot though. See, it's way cooler now. As soon as it gets that frequency, that it cools way down to normal. So it's pretty interesting anyway. Do that again. It's a pretty big cap too. So you can tell it takes a bit to charge it up. But I won't be able to do that again unless I move this one over. I don't want to kill that gauge. I have to tap it because it's pulling a lot of current now. As you can tell, it's pulling like 3 amps. But yeah, I just wanted to show this video because, like, if you do build one of these, you have to fill it up with current, with power, before it'll start to do anything. You have to fill that, because these coils have capacitance to them, so you have to fill it up. Like, this coil's way more efficient than this one is. This one was really giving some really wicked results, actually. I was able to bring the battery voltage up. So I'm curious to see what I'm going to be able to do with this one. But thanks for watching, guys. Hey guys, so I got this big ringer here now. Still the matte glass core in there. Just use big hole saw like this. One smaller, just the next size smaller than this one. Just cut out a couple centers. So I got a few options. Another size up, or you can even make a bigger one. This is 4 3/4, I think. But anyway, this is I think there's 9 ohms or so. I can't remember the exact numbers. I'll have to recheck it. But I think there's 9 ohms of the number 19 and somewhere around 11 or 12 with the number 24 gauge. On the number 24 is on the bottom, 19 on top, and it's heavy too. It's all resin together, so nothing vibrates in the coil. It's solid. So I want to show something here. I'm just going to kill it a little bit. See, there's the voltage of this cap at 63 volt, 10,000 UF. Yeah, that'll be enough. So when I first hook it up, it gets to a point where it gets just over the battery voltage. Below the battery voltage, it pulls quite a bit of current. And then once it gets above the battery voltage, it begins to saturate the coil to where the capacitance is in the coil. It takes quite a while to get it to where the capacitance is in the coil. After that, well, you'll start to hear it to ring at about that time when it's getting full. But when it's completely full, I think it's close to 50 volts. It hits, and you'll see the current on this meter will go to 0, and the ringing goes away, and everything becomes cool, and it charges hard. So I'll just turn this on. See, it's filling up. I just got it. I'll just pause this and get everything in frame. Okay, it should be in frame now. I'll just hook it back up. There you can see how many watts it's pulling and the voltage of that cap. After it gets above the battery voltage, you'll hear it start to ring. There's the ringing. Watch as it hits about 47, 40, 46-ish, 47 volts. I think it is. Somewhere around there, the ringing will stop and the current will go to 0 on that meter. Here the frequency's changing. I have to stop around 60 volts because it's only a 63 volt cap. I don't want to blow it up. Still hear the ringing. Still ringing. Seems to start to charge faster here too as it gets quieter. Current goes down. Hopefully that inverter shuts off. There it should. There you go. It just went away. The ringing went away. Still charging. No more current draw. The coil's full. It's in resonance. Resonance. So yeah, if you build one of these and you notice it's taking a lot of current right off the bat, just let it do its thing. Just let it build up. If you're seeing the voltage in the cap rise above the battery voltage, then it should be hooked up properly. There, I'm going to stop it here when it hits 60. I don't want to blow up that cap. There you go. Set. Discharge it. Oh, I didn't mean to do that. Shorted it right out. Welded it together. At least it's discharged. Thanks for watching, guys. Figured you might want to see something like that. How the coil builds its capacitance.